Now it's time to understand the principle of conservation of mechanical energy. Very first case, maximum height. So here the red line represents the maximum height. Let's say this is the maximum height h, and this is, let's say, at C point. This is C point, this is B point, and this is A point. So this is C point, this is B point, and this is A point. The maximum height is h. And C to B, this height is x. So total height is h. So A to B is h minus x. So this is the very basic idea of this concept. Now our main objective is to prove that at A point, at B point, at C point, the total energy are equal. In that case, we can say that the conservation of mechanical energy at every single point of ABC. So very first point is C. So at this point, the object is this one. So when the object is at C point, so at C point, their h actually 0. So the potential energy is obviously mgh. So h is 0, so it will be 0 joule. So if we throw this object towards upward, so the maximum velocity we have to apply here. So here the maximum velocity we apply here. As a result, the kinetic energy will be half mv square. So total energy at point C is equals to, this is Ek, so Ep plus Ek is equals to half mv square. So this is total energy for at C point. So at C point, let's say the velocity is Vc, so obviously this will be Vc. And when this object goes towards the maximum point, at this point the velocity, the final velocity, of course it will be 0, and then it will be again fall down, right? So the equation for the final velocity v naught, I mean this v square, is equals to vc square, as this is goes upward against the acceleration due to gravity. That's why this is minus 2g, and the maximum height is h. So we could write down v naught is 0, so vc square minus 2g h. So we could write down vc square is equals to 2g h. So if we plug in the value of vc square here, so at C point, the total energy will be half m, and v square 2gh. So these two cancel out, so we could write down mgh. Okay, so now it's time to determine the total energy at B point. So at B point, the potential energy Ep, let's say B, is equals to mg. How much height it will be? It is x, so we have to write down here x. So the potential energy is very straightforward. but the kinetic energy will be half m VB square. So what is VB? So here is VC and here is VB, right? And the distance is x. Indeed, what you can write, we can write VB square equals to VC square minus 2gx. And what is the value of VC? VC is 2gh. So here let's write down this equation here for better understanding. So we could write down VB square is equals to VC square. So VC square is 2gh minus 2gx. So 2gh minus x. Now it's time to plug in this value of VB square here. So we could write down half m. VB square means 2gh minus x. And here it is very straightforward. Let's cancel out 2. So we could write down mgh minus mgx. So at B point, the total energy, let's say EB is equals to EK B plus EPB. Now it's time to plug in the value. So EKB means mgh minus mgx plus the value of EPB is mgx. This value we have to plug in here. So mgx cancel out. So the total energy at a B point is mgh, which is equal to the total energy at point C as well. So remember, the value of total energy at C point same as at B point as well. Now it's time to calculate at A point the potential energy EPA is equals to mgh. So of course here the total energy is mgh because the maximum height, remember the image represent from C point to A point, so maximum height is traveled by this object. So and the mass is m and the maximum height is h, and the kinetic energy EKA is equals to half mv square. Remember the value of the velocity at A point, v is 0, so there is no velocity exist. In that case it will be 0. So the total energy at A point E equals to EKA plus EPB, so mgh. So at every point, at A point, at B point and C point, every point the total energy is mgh. So conservation of mechanical energy is conserved. So we proved that at every point, at A, B, and C point, the total potential or total energy is mgh, so which is equal.